All right. Hello and welcome everyone to the Intrepid Museum's new live virtual programming. Thank you so much for joining us today for Star Stories. We're so happy that you're tuning in, and I'll be answering a number of your questions throughout the program today. So my name is Alicia, and I'm an educator at the Intrepid Sea, Air, and Space Museum in New York City. And I will be your host throughout the program. If you have any questions, as a reminder, you can just put them in the chat for me, and I'll do my best. Now, our live streams are free, and if you'd like to support us in delivering this exciting new content, please do click on the link that are going to be in the comments or the description. So again, use the chat today to say hello. Let us know where you're tuning in from. Let us know if you've ever been to the Intrepid before. And of course, if you have any other questions, you can put them there. So today we are going to be talking a bit about the Intrepid's connection to space. So why we are a space museum. And then we are going to talk about stars and a few constellations that we can find up in the night sky and how the stars have been used to help guide people out at sea for generations. So you see, a long time ago, we didn't really know much about our world other than what we could see immediately around us. And it wasn't until we started to go up into the sky and into outer space that we really got a sense of our planet and the rest of our solar system. And that all really just started by us looking up. So let's get started. All right, everyone. So to start off, this is the Intrepid Museum. It is actually inside the former USS Intrepid, which was built in 1943 and served in 3 wars. So that's World War II, the Cold War, and the Vietnam War. And it was retired in 1974 and then later made into a museum in 1982. So we are currently docked right off the shoreline of Manhattan in the Hudson River. Now, if you're a local, maybe you visited us before, or maybe you've passed us along the way. It is really quite a beautiful thing to see on the outside, and it is really, really big and kind of hard to miss. But I have to say, inside is where the magic is, where we store a lot of our really cool artifacts. So this is one, or two really, because the ship itself is an artifact. But here's one on the right, for instance. So this is one of the 4 propellers of the Intrepid. Now, one of the things that helped to move us through the water, and again, we had 4 of those. And that is, of course, why we're a sea museum. You can see in this picture, because we were a naval ship out at sea during times of conflict. So in this image on the left, you can see the ship racing along here through the ocean while we were in service. Now, at the Intrepid, you will also see a number of planes. And that is one of the things that we are probably best known for, because we carried planes. We have a very special name, too. So can anyone in the chat maybe tell me what kind of a ship we are? What do you call ships like the Intrepid that have those airplanes on them? See if there's a name for that. And here are a couple that we have, of course. We've got the Avenger, the big blue one there on the left from World War II, which was a torpedo bomber. We also have that white one on the right there, the Fury, which is a jet plane. So that one flew really, really fast during the Cold War. So planes like these are, of course, why we are an air museum. The Intrepid could fit up to 100 planes inside at a time. And it could also launch and land these planes from the flight deck, kind of like a floating airport. So our ship is called, you may have guessed it, an aircraft carrier. There you go. Long Jeb Silver. Exactly. We are an aircraft carrier because it carried aircraft across the ocean. But the space part is what sometimes confuses people. Why are we also a space museum? Well, take a look at this. So can anyone tell me what this is? Now, it is this big black kind of light bulb shaped thing that says United States on it. All right, there's that flag that we recognize. Now, some people say it kind of even looks like an ice cream cone that's tilted on its side. So this is something that we call a space capsule. And it is very special because this is how astronauts used to go into space. Now, looking at it, you can probably see that it is not very big, right? So maybe you can tell me in the chat also, how many people do you think could fit inside of this capsule? Capsules like these rode up on top of a rocket. So, of course, the rocket is the thing that goes up into space. There's lots of fire that comes out of the bottom, right? But then they separate from the rockets once they get into space, and then they're up there floating around to complete their missions. So a while ago in the 1960s, during the Cold War era, NASA, our space program, was part of something called the space race with the Soviet Union to get to the moon. But of course, you don't just, roll out of bed and end up on the moon. We had to take a number of other baby steps to get there first. So things like figuring out how to even get up into space, then of course how to breathe up there in your capsule and eat and sleep and work for long periods of time and so on. So these capsules were part of some of those very early steps of NASA. They called it Project Mercury. And this is what the Mercury capsule Aurora 7 looked like. Now here, you can see it on top of that rocket there on the right. So it's that little black cone that's on top of the rocket. And yeah, again, very, very small. And only one person could fit inside. I see you said that too in the chat. Awesome. So exactly. Now in 1962, an astronaut named Scott Carpenter, who you can see on the left here, went up inside of a Mercury capsule just like this one. And well, have we ever heard of that word before? Mercury. What is Mercury? Why do we call these missions the Mercury program? Any ideas? Well, let's take a look. Now, you might have heard of Mercury before because, yes, it is the name of one of the planets in our solar system. It and many other planets got their name from Roman mythology. So Mercury was the name of the messenger god. He was kind of like, I guess you could say, the mailman. He was delivering messages around to everyone, and he was known for being really, really fast. You actually might see him depicted like this a lot. So you can see those wings on his helmet and those shoes. So that makes him go super, super fast, those wings. So the planet Mercury is both our first planet from the sun, and as its name might suggest, it is also our fastest planet. So 1 year on Mercury takes only 88 days, whereas it takes us, of course, 365 days here on Earth to go all the way around the sun. So, America wanted to be the first and the fastest to get to the moon. So back to the Aurora 7 and Scott Carpenter. At this time in the space program, when capsules came back home and came back down to Earth, they wanted to land on a softer landing spot. So they would decide to splash down into the water, into oceans with parachutes, of course, to slow them down. And then, of course, afterwards, since they were just out there kind of floating around in the middle of the ocean, someone would have to go pick them up. So a helicopter would come to rescue the astronaut. And in this image on the right here, you can see Scott Carpenter right after his mission being retrieved and flown to safety. So then after that happens, you still have the capsule floating around. Divers would come to retrieve the capsule. Then they would bring it on board to the closest ship to eventually then end up, of course, in a museum. Now, the Intrepid is really lucky because we got to do this for 2 space missions. It played a really important role in picking up the astronauts, the ship did, and their capsules, of course, too, after they returned from outer space. So, ladies and gentlemen, that is the reason why we are a space museum. In fact, here is Scott Carpenter on board the ship right after he was picked up by our team here at the Intrepid. He is still there in his Mercury spacesuit. He's surrounded by officers and onlookers on board the Intrepid after being picked up in 1962. So a very, very special occasion. Now, after the Mercury missions and Scott Carpenter, NASA sent up some other astronauts. Now here you can see Gus Grissom and John Young, and they went up inside of the Gemini 3 capsule. And similarly, when they were done, they also splashed down into the water and were retrieved by the Intrepid in the very same way. But I want to talk a little bit about the name of those missions for a second, too. The Gemini missions. So what does Gemini mean? Does anyone know? You can tell me in the chat. Maybe take a look at some of these pictures and think about how maybe they're different than the Mercury missions that came before it. And remember, this was called Project Gemini. So yeah, what does that word mean? Have you heard that before? Gemini. What is Gemini? Where have we heard that before? What might it represent? Well, here are those 2 guys again, Gus and John. And yes, Gemini is, if you were thinking, a constellation. It is up in the night sky. Now, what is a constellation? Well, it's basically a picture that's up in the sky that's made up of a grouping of stars. Now, a long time ago, people would actually connect the dots of the stars up in the sky to make it look like things, pictures and animals and people. And they would tell stories about what they saw up there. So yeah, take a look at that Gemini constellation on the right. What does it kind of look like to you? I see it in the chat. Spyro welcome back. Yeah, twins, right? So it is the constellation of the twins. And thinking about that and thinking about our friends Gus and John here, who to the left of them, who went up into space together, now maybe we can start to understand why we called this the Gemini Project. Because it was the first time that NASA sent 2 astronauts up into space together. All right, so I want to pause really quickly before I get into more constellations. And I just want to see if anyone has any questions to start off with about Intrepid or any of our early missions. So let's see. Were any other NASA programs named after Greek mythology? Oh, I love this question. Yeah, so pretty much all of them, actually. You've got Mercury and Gemini, of course, that I just talked about. And then we have Apollo, probably one of our most famous missions, which took us all the way to the moon, which is kind of ironic because Apollo is actually the god of the sun, not the moon. But they really liked the idea of, that image of him flying his chariot of fire across the sky, kind of like our big, powerful rockets with all the flames and all that he represented for the mission. So that was, of course, Apollo. Now we've got the Artemis missions coming up. So Artemis, a little more appropriately now, actually, was the twin sister to Apollo, which is very symbolic because it's also the name of our missions that are going to bring the next man and the first woman back to the moon. So his sister, kind of nice with that there's a female deity there. And actually, I think it is also really interesting and kind of funny too. Not a lot of people know this. Project Mercury was originally suggested to be called Project Astronaut. Can you believe that? And remember now, this is before we'd actually really use the term astronaut. This is when we were first creating astronauts. And they got that word from the naming tradition that started with Argonauts. So you might have heard like Jason and the Argonauts. So those were the Greeks who traveled around on the ship the Argo in search of the Golden Fleece, right? And then that continued on with things like the aeronauts, which were the people who kind of pioneered the idea of flying in hot air balloons. But they didn't want to make it so much about the people, NASA, so much as really about the mission as a whole. So they canned the idea of Project Astronaut and they went with Mercury instead, which focuses more on the goal of the mission. But we also do have things that are like rockets that are still named after mythological things in Greek and Roman mythology. So we've got Thor, we've got Atlas, Centaur, Saturn, of course, the Saturn V rocket. And we've had spacecraft too, like Aquarius, which was the lunar module that ended up being the lifeboat for Apollo 13, if you know that story. And now Orion, which is the newest series of capsules that they're using for NASA. So yeah, it just kind of started off and they kind of stuck with the naming tradition and went on from there. How many constellations are there? So there are 88 officially recognized constellations in the night sky. We are actually going to be talking a little bit more about those, a lot more about those in the rest of the program. But of those 88, there's actually only 52 that are visible in the northern hemisphere. So that is above the equator. The constellations that we recognize were originally described by the Greeks. So there's a lot of Greek and Roman mythology there with their namings. So it does correspond with their myths and their stories. And while, of course, they are not the only civilizations to find these images in the night sky, they're the ones that are the most commonly recognized today. But I'm going to be telling you a little bit about some other stories today, too, from other cultures as well. So why don't I dive right in, actually, and keep doing that. So let's move along here. Now, everyone, I'm actually going to switch off my screen here and show you something a little bit different. I'm going to be using a program today called Stellarium, and I apologize if my screen gets a little bit choppy as I go to do this. But I am going to be using this program called Stellarium. You can find it online, and it's a wonderful program that will allow you to view the night sky as it is right now. So let me just pull this up for us. Oop, got the wrong one. Hold on one second. All right, so it's going to allow us to see what the night sky looks like. And you're also going to be able to see things like planets and some really interesting stories as well. So here we go. There it is. Alrighty. Excellent. So here we are. This is called Stellarium. Again, you can find this online, stellariumweb.org. There's a hyphen in there. That's if you want to load it on your computer. Otherwise, you can also download it. I'm sorry, when I say on your computer, I mean on the internet in a web browser. But you can also find it on their website in order to download it as well. So what I'm going to do here is I am going to tell it to find what it looks like in New York City right now, because that's where I am. And I'm also going to make sure that it is this exact time right now too. So now we see that we have that lovely blue sky. It is February 25th at 3:15. So this, believe it or not, is New York City. All right. So I know it doesn't really look like it, This is an image from actually, I think, a field in France somewhere. But let's use our imagination. Maybe we're in Central Park or somewhere that is a bit more open and grassy. So let me ask you this right now. When we are looking up at the sky here, can we see any stars? Not really. We don't really see too many stars here. In fact, we can see one star, the sun, of course. But no, we have an atmosphere that clouds our view when it is daytime. But, my friends, have you ever wondered why the sky is blue? Now, a lot of people have wondered this throughout the years, all right? And it's actually kind of a simple explanation. People, have a lot of thoughts. They say, is it because our Earth is covered in so much water, so it's the reflection of the oceans? Nope, that's not it. Or, maybe there's even an ocean up in the sky, and that's how it rains. No, everyone, that is not it. So the real reason why the sky is blue is because of our atmosphere. That is the bubble that surrounds our Earth. It just, scatters blue light really, really well, all of the oxygen up there. It takes the light from the sun and it scatters the blue spectrum of it all around. And that's why we can't really see stars during the day. So, although the atmosphere does a lot of really good things for us living here on Earth, it's not really the best for looking out at stars. Now, technically, yes, like I said, we can see one really big star. We can see the sun. That is our own special star, but that's really all we can see. And it's so bright that it really messes with our view of the rest of the stars from scattering all that light. So in this program, we can actually get rid of our atmosphere. Not in real life. We don't want to have to hold our breath or anything, but here we go. Now, I have just taken the atmosphere off. And here we can actually just look up and see the stars. So there they are, my friends. They are actually all there all the time. They're just hidden until the sun goes down. Now, when throughout history people have looked up into the sky, it might have looked like, well, just kind of a bunch of random white dots on a black piece of paper or something. In fact, Native Americans in the Pacific Northwest believed that at one point the sky was nothing but darkness. So they said in their culture that a young member of their tribe made a mask out of wood. He set it on fire, and he began to travel across the sky to light it up for us. So effectively, he's our sun. And then at night, he would sleep below the horizon, and that all of the stars that we see were just sparks and embers that flew out of his mask. But a lot of cultures also started to notice that the stars were always very consistent, and their patterns always stayed the same. So as they started to realize this, they eventually even began to map out the sky and identified groupings of stars, which are, of course, the constellations I mentioned. Now, remember before I showed you that picture of Gemini, and the lines were all drawn out and connected and easy to see for you? Well, of course, looking into the sky here, there's no lines connecting it. It is just kind of a smattering of those white dots, like I said before. We have to use our imaginations in order to group those pictures. But again, what is really cool about this program, everyone, is that I can add the lines to the sky for us. So now we can more clearly see those constellations much, much easier. And believe it or not, if we look up into the sky right here in the east, we can see the constellation that we just talked about, Gemini. There it is. So let's zoom up on Gemini here and take a closer look. Gemini is, of course, again, the twins. Those twin boys, you can see them much more clearly here. And there's a story that goes along with these twins that are in the sky. Now, the ancient Greeks saw these groupings of stars, and they decided to come up with stories that teach us lessons and to remember stories of great people and their gods who are important to them. So the story of those twins goes like this. Once upon a time, there were two brothers. Their names were Castor and Pollux. Now, Castor and Pollux had the same mom, but different dads. So Castor's dad was just a regular mortal guy, and Pollux's dad was Zeus. He was the king of the gods. And that meant that Pollux could live forever. Well, this didn't bother the two brothers too much. They were best friends. They did everything together. They played together. They went to school together. You never saw one without the other. Now, a war broke out when they got older in their country. So Castor and Pollux decided to join the army and to go fight in the war. But then something really sad happened. Castor was killed. Now, Pollux was heartbroken because his best friend was gone. So Pollux went to his dad, Zeus, and he said, I know I'm supposed to live forever, but, I really miss my brother. He was my best friend. Would it be possible? Can I give half of my forever, whatever that means, to my brother so that I can be with him? Now, Zeus was so touched that his son was willing to give his life for his brother like that, or half of his forever, that he did something even better. So Zeus brought Castor back to life, and then he put the two brothers together up in the night sky so that they would never have to worry about being separated ever again. So that is Gemini. That is our Gemini constellation right here. So, can you think of any other constellations? Maybe you can throw some in the chat for me. Everyone, if you know your zodiac sign, which is based on the time of year that you were born, that is also a constellation. For instance, if your birthday is today, February 25th, you would be a Pisces, I believe. So that means that the sun was moving along its path called the ecliptic, and it was currently in that constellation of Pisces. Now, another star grouping that people might have heard of is the Big Dipper. So I have another question for you all as I fast forward time a little bit here and we can see the Big Dipper a little more clearly. Is the Big Dipper a constellation, everyone? Question for you there. Is the Big Dipper a constellation? You can really see it right clearly here with these stars. There's the handle and there is the bowl. So is the Big Dipper a constellation? Yes or no? So the Big Dipper, everyone, is actually not a constellation. It is part of a smaller, or it is a smaller part rather, of a constellation. So that constellation that it is part of is this one right here. This is Ursa Major, the Great Bear. And you can see it right in that back half of it. There's the tail, and there it is, kind of in the butt of the bear right there. So it is a smaller grouping of stars within the constellation. And it is something called an asterism. That's that smaller grouping, like I said. What's cool about Ursa, or rather the Big Dipper, is that it's got two stars called the pointer stars that are these two right here. I'll get rid of this part. Oh, actually, I'll leave it on. So these two stars right here actually point to this star right here, Polaris, which is our North Star. So that is the tip of Ursa Minor, which is the little bear. And I'll light that one up for you too. Actually, I'll just put on all the artwork for you. All right, so you can see Ursa Minor, this one right here. It's a smaller version of Ursa Major, the Great Bear. There he is. So the little tip of his tail there is Polaris. Now, again, that is our North Star. And Polaris is very important because that is what navigators would use to map out the night sky. And if we fast forward in time, I'll zoom back a little bit here. I want you to keep an eye on Polaris right there, all right, that star. And I want you to see what happens. I'll turn off all of this stuff too. Keep an eye on Polaris and notice what happens to all of the stars as we go around it. Let me make this a little bit bigger for you. Keep an eye on that dot. Here we go. As I fast forward, you'll notice that dot in particular does not move, but all of the other stars going around it does. All right, so that fixed point was very, very important for navigators because that was a constant that they could always look to in order to be able to see where they were going. So always knowing where north was extremely valuable to them. Now, there is another story behind Ursa Major, the Great Bear. Let me bring him back on screen a little bit more centered for us. And this one is actually a really fun story to learn about. This one is from the Iroquois tribe. So this is a Native American tribe out of the northeast of the United States. So here is our Ursa Major right here. All right, now here's the story about Ursa Major. Once upon a time, there was a great and terrible bear terrorizing the land. So it was eating all of the food. And all of the tribes decided to get together and decided they needed to do something about this bear. So they sent their 3 bravest warriors in all of the land to go hunt the bear. Well, the warriors were really good, but the bear was always one step ahead of them. So they chased this bear all around the world. They went through mountains, they went through the ocean, they went through the desert. Finally, the warriors were starting to catch up to the bear, and he realized this. So as a last attempt, he took a giant running leap, and he jumped into the night sky where the warriors couldn't get him. But right before he got into the sky, the bravest of those 3 warriors let loose an arrow from his bow, and he struck him in the back leg. Now, the warriors vowed that they were going to be ready. If this bear ever came back down from the sky, they were going to be there. They were going to get him once and for all. But they say to this day, he is still hiding up there in the sky. There he is, Ursa Major, the great bear. And every year he comes close to the earth to see if the warriors are still waiting for him. Now, the warriors know that if he's close to the earth, though, whenever that does happen, because a little bit of the blood from his wound and the bear's injury dips into the trees and changes the leaves' colors. So that was a way for them to explain the seasons. And I'm going to show you actually. Let me recenter this just a bit more. Now, watch what happens here. I'm going to actually go through the seasons. Right now, we're in February, but I want to go back to about, let's say a few months before. Can anyone think of a time of year when all of the leaves change color? All right. So let's start with, let's go back and let's see what happens here. You're going to notice as we get into the evening hours, as the night is starting to fall, this is a time when he starts to dip below the horizon. All right, so here we are starting in about August. As we move on to September, October, this is about the time when the leaves change, right? November, December. So in that fall time, that's when he's dipping down and that blood from his injury is dripping into the trees. So again, they were able to make a reason for the seasons then, really. And they said again that was his blood dipping down into the leaves, changing them to that pretty red-orange color. Kind of a cool story. Now, we talked a bit about asterisms, right? So the Big Dipper is an asterism. Let's go back to where we are today now. The Big Dipper is inside of Ursa Major. It is a smaller grouping of stars. It is an asterism. But are there any other asterisms that you can think of in the night sky? Maybe even kind of in this area. There's another one that's pretty common that we can see even here in New York City where it's difficult to see stars. So again, we're thinking of a smaller grouping of stars that you might have heard about before. And I'll give you a hint. The one I'm thinking of is an article of clothing. Something maybe that keeps your pants up. Anyone know? Yes, of course, I am talking about a belt. Orion's belt right here. So Orion and his belt right here. Orion's belt is a cluster of 3 stars right here. And they're very, very easy to find in the night sky. They're very bright and they're close together. So Orion here is the hunter. You can see him with his bow and arrow and his he's got a lion, actually, a lion skin here and a club. So he was a hunter in Greek mythology. It was said to kill Taurus the bull, which is right up here, right next to him. And he thought that he thought that he was the best hunter that ever lived, really. He bragged a lot about it. And of course, we know it's not very nice to brag and go around telling people that you're better than them. Well, Orion was friends with Artemis, who we mentioned earlier, the goddess of the moon and also the goddess of the hunt. So she respected animals, and she believed that you should only be killing animals if you needed them for food or for survival. You shouldn't just be killing them for sport. But Orion kept wanting to show off and kept killing animals for fun. So the other gods took note of this, and they didn't like it. They decided to punish Orion by sending a giant scorpion after him named Scorpius. So they fought long and hard, and to this day, they are still chasing each other through the night sky. But here's the really interesting thing. You will never see the two of them out at the same time. They are on opposite sides of the sky. So I'm actually going to show you this. Again, here we have Orion. He's lit up, all right? But as we move through time, this is kind of a strange view that you're going to get here. Let me see if I can even out the horizon a little bit. As we move through time, you are going to actually notice a scorpion come up over the opposite side. So let's actually face the other direction. Bear with me here. Alrighty. So we're going to notice now, as he's going down, we are also going to see a scorpion arise. So watch what happens. She's going to come up on the other side. So as we go, you can see a lot of these other things coming up over here. But here he comes right up over the horizon. There is Scorpius. He just came up right here. And on the opposite side of the sky was Orion setting. So the two of them are constantly chasing each other throughout the night sky, but the curse is that they will never, ever be able to catch each other. So that was kind of a punishment for him. Let me see if I can actually show that a little more clearly now that I have it in the right view. There he is. So there's Orion right in the center. All right. And as he goes down, you're going to see Scorpio come up on the left side. My computer keeps freezing. All right. Well, you saw it before. I apologize. I'm having a little bit of technical issues right now. There he is. All right. Perfect. So yes, they are always chasing after each other. Now, Scorpius is actually the name of the constellation that it was used in Moana, if you've ever seen that movie. That is Maui's fishhook. You might recognize that shape there if you've ever seen the movie Moana, which is set in Polynesia. So that's the Pacific Islands. That's the hook that the demigod Maui used to pull up the Pacific Islands, like Hawaii, in all of their legends. So that's a famous Polynesian constellation tale. And there's actually another Polynesian tale also related to Orion. So I'm going to take you back to Orion, if it wants to cooperate. There we go. Let's look at Orion again. And let's talk about, again, that belt. There is a wonderful Polynesian tale related to his belt. Here he goes. There's Orion. Alrighty. So let's take a look closer at those three stars. Now, in Tonga, which is an island in Fiji, or near Fiji, rather, out in the Pacific, these three stars that form his belt tell the story of Hina and her pet shark. Now, Hina was a beautiful young girl, and one day while her brothers were fishing, they caught a baby shark. No one sing that song, please. It's an earworm. They gave the shark to Hina as a pet for her birthday, and they created a pool in the reef for the shark to live. And so Hina watched over it and became best friends with it. But one evening, during a violent storm, it blew down a lot of buildings on the island, and it damaged the reef where the shark was living. So the waters rose up, and it swept the shark out into the big, wide ocean, and it swam away. Now, Hina was devastated. So she was just completely so sad that she begged her parents to please take her out to sea to find her shark. So she and her parents searched the ocean far and wide until finally a fin emerged out of the waters. Now, Hina knew deep down in her heart that this was her shark, and she begged and begged to return with her. But the shark had tasted its freedom out in the ocean and was like, nah, I don't want to go live in that teeny tiny coral reef pool. I want to live in the big wide ocean. So it didn't want to go back. Now, Hina was very upset by this, and she didn't want to leave her best friend, and she couldn't bear to be parted from him. So their canoe rose up into the heavens, and they say that those three stars, which they call Alatulu, are which means three in a boat. They say that that is Hina and her parents up in the sky, staying there with the baby shark. So, everyone, I'm going to pause again. Let's see if oh yeah, it's going to be super choppy. I apologize for that. So I'm going to keep it on this screen. But if we have any questions, let's see if I can answer any of those. So any questions? Oh, why do stars twinkle? Okay, so yeah, stars often give off that kind of flickering, twinkling movement a little bit. Someone should write a song about that. Maybe a twinkling little star. I don't know. Well, that is actually light bending as it comes through the atmosphere. And as it comes through, it slows down and it makes it look like they're twinkling from here on Earth. So it's actually kind of an illusion to us. But when we go into space, the stars look a little different and a bit more steady. So it's kind of a special added effect that we get from looking up at the sky here on Earth. So nice question. What else? Why can't we see stars in New York City? Oh, yeah, I kind of mentioned that. So I mentioned that the sun scatters light around the atmosphere during the day and that it covers up the stars and so that we can't see it until the nighttime, right? Well, the same thing happens here in New York, but it's coming up from the earth at night from New York City or really any big city. So when you have a lot of lights, street lights and cars, I guess streetcars too, or tall buildings and things like that, they're emitting lots of light pollution from the ground up. So all of that light gets scattered around as well, and it blocks out our ability to see those stars at night. But if you ever go camping or someplace that is just a bit further out away from all of the lights of a city, you will see a billion stars come out there. So stargazing can be a bit tricky here in the city, but we can certainly see on clear nights a few of them, but definitely not as many stars as you would see if you were, out in the desert or something like that. Alrighty, so let's keep moving along. Something else that we can see that's pretty cool on this program, everyone, are planets. So we'll take a look here again. The last thing that I can show you here, actually, that I'd like to show you here, is that, in addition to these ancient cultures, of course, noticing the constellation star groupings, they also noticed some other really big, bright things up there. So, of course, those are our planets. But they noticed that those things, instead of staying put and staying in one place, they actually were kind of moving around. They were wandering throughout the sky. So the ancient Greeks named them for their word that meant wanderer, which was planetes. And just like it sounds, that's how we get the word planet today. So we can see planets in our night sky as well. Oftentimes, you can notice them by their color. So, for instance, right over north of Orion, where we were just looking, right here, we can see Mars. So this is a planet that's been in the news quite a bit lately because, of course, we just landed our Perseverance rover on it. So let's take a closer look at Mars, shall we, with our program here. I'll zoom in here. Now, Mars appears in our night sky, of course, as a red dot, kind of like a big glowing eye or maybe even blood. And as a result, that's how it got its name, too. Mars is named for the Roman god of war. So it gives off that color because of all the iron oxide that's covering the surface. It's like a dusty layer of rust all across the ground. And if we zoom up on it, we can actually see things like craters. And even sometimes you can see, let me actually go through time a little bit. I'll see if I can find it exactly for you. The Jezero crater, which we just landed on with the Perseverance rover. Gotten pretty good at spotting it. Let's see if I can find it here now. Going through time. Sometimes we can see it. Sometimes it doesn't want to cooperate. Yeah, it doesn't want to cooperate right now. But you can actually find it pretty easily if you can find the ice cap. And you go kind of to the side of the ice cap. There is oh, there it is. Wait a minute. I just got it. Okay, great. So there's an ice cap that's going to be right up in the top over here. And there we go. So it's going to be right up here. And then there's this crater that kind of looks like a chevron kind of pointing down. And this right here is where we're looking. So specifically, the Jezero crater that we just landed is in this area. So they're currently searching for possible signs of past life in the area. They believe it was once an ancient river delta and lake possibly even. So that's Jezero crater. And again, that is right about right here, if you can see my arrow. So it's kind of neat. You can even see that on the program too. But Mars is gorgeous. We've got all that iron oxide all over it, making it that red color. Now, everyone, I also want to mention something else that is super cool. I mentioned Moana before. If you've ever seen that movie, you'll notice that while she's out there adventuring in her boat, singing great songs in the ocean, you might have seen her actually use some tricks of celestial navigation that our ancient mariners used to use. So she uses the stars, of course, to figure out where she is going. And remember that we said Polaris, the North Star, was really great at helping sailors to figure out where north was. And the ancient navigators had some other tricks up their sleeves, too, kind of literally, if you take my terrible pun, where they were in the world. And that is because they literally used their hands. Get it? It's like up their sleeves. All right. So I'm actually going to, let's see, remove this and close this. And I will demonstrate for you my back. Oh, what a terrible way to freeze. There we go. All right. So I'm going to actually demonstrate for you how you can use some tricks of celestial navigation using your hands as well, because you've got those up your sleeves too. Now, it's certainly not the most precise way of doing things, of course. Eventually, they developed gadgets to help them out. And now we have, GPS and all of that. But I'm going to teach you some things that you can do with just your hands. So we're going to be looking at something called latitude. So if you've ever seen a map, you might notice that sometimes they have lines that go up and down and side to side. So these are coordinate lines of latitude and longitude, and they can help to tell you exactly where you are on the surface of the earth, where something is, especially if you're out sailing in the ocean. So the equator is the line that goes across the center of the earth, right? It's like the belt, the waistband, right? We'll say it's at 0 degrees latitude. And then depending on whether you go above that line or below that line, you are going north or south. And you're going north or south by a number of degrees. So they use degrees. It's not like temperature, it's actually distance. So the Intrepid used coordinates like this when they were sailing too, but of course they had much fancier gadgets to tell them where they were, and now they have even better ones too. But let's pretend if you were outside looking up at the sky and you were to extend your arms out, okay? So you can try this at home with me. Extend your arm out as far as it can go, okay? And this is going to be now relative, obviously, to how long your arm is, but it actually sort of equates out depending because everything in human bodies are roughly proportional. So if you extend your arm out at that relative distance, all right, the width of your pinky finger is said to be 1 degree. Now, it looks bigger because I'm closer to my camera here, but to my perspective, it is maybe a little further away, so it's a little smaller. So that is about 1 degree. If you put that on the horizon, that is going to be 1 degree up. Now, then they say that the width of your knuckles across your hand here is 10 degrees. So that's a good rule of thumb there. All right. Or you can do a fist there. So it's a rule of fist, maybe. And then they said that the span of your whole hand outstretched. So from thumb to the tip of your fingers there. So you can either do it like this, you can either do it like that, or you can extend your fingers out like that. From here to here is about 20 degrees. So actually, if you do the 10, it actually really does line up, believe it or not. So based on those measurements, everyone, you can actually count out how many degrees up from the horizon the North Star is if you live in the Northern Hemisphere to determine your latitude, so how far north you are on the planet. So for example, New York is just over 40 degrees north on a map if you look at it on the coordinates. So you could figure that out a few ways. You could go fist over fist from the horizon. You would be up 4 fists up from the horizon because that's each of them is 10. Or you could do 2 hand spans tall. So those are, about 40 degrees there. But, what if you're not in New York City? Let's say you are further south. You're in Mexico. Maybe you're in Mexico City. That is 20 degrees north because it's further south. It's closer to the equator. So you could then, if it was just about 20, you could use, again, 2 fists or just one of your outstretched hands. And if you do this, you want to put it so that the tip of your thumb is kind of resting right on the horizon like that, and then it's up to here. So try it out, wherever you are. You can always estimate how far north you are just based on using your hands and the North Star. Now, for people in the Southern Hemisphere, south of the equator, people like Moana, they actually can't see the North Star. As I mentioned earlier, we see different constellations depending on which hemisphere you live in, because the Earth is tilted kind of on an axis there, or on its axis rather. So when we look at the southern sky, we don't see the North Star. Instead, they use something called crux, or the Southern Cross. And so these are actually kind of like pointer stars as well. So you are able to then look at that constellation, and you can kind of estimate then where the South Pole is that you'd be looking at. And then it would be roughly the same thing there. You'd want to draw kind of an imaginary line to what that is. And then same thing with the degrees. You can use your fists and figure out where you want to, or where you are latitude wise. So Tonga, for example, where we told that story about Hina and the shark, is at about 20 degrees south. So same thing. It would just be 2 fists or 1 hand length on the horizon like that. And that's the 20-degree line. It's really cool. So maybe if you go outside tonight, if you can see some stars, if you could see Polaris, the North Star, see where you are and see if that works out, and see, check on a map what your coordinates are depending on where you live, where you're tuning in from, and test it out. And you will be just like one of our earliest celestial navigators out at sea. So everyone, that is the end of our program for today. But I do want to ask if there are any other questions before we wrap it up. So let's see. Any other questions? If the atmosphere gets in the way, how do we get good pictures of outer space? Yeah, so it can be, and especially if we have, light pollution, like I just mentioned as well. How do we get good pictures? Well, we have telescopes, first of all, that can see very far out into the universe, but telescopes from here. But we also have things like the Hubble Space Telescope. So that is a very, very powerful telescope that we put out outside of our atmosphere. We send it up into orbit around our planet. And then once it's outside of the atmosphere, we don't have the atmosphere, ruining our view of the stars. We were able to get much, much clearer images. And of course, they were able to keep visiting Hubble and upgrading its technology to make it look even better as the years went on. And now we are about to launch the James Webb Telescope, which is going to be even much better as well. So once we get that one up there, we'll be able to see even further distant stars too. But that's basically how we're able to get those gorgeous pictures of all the nebulas and all the stars, those deep field images of Hubble. That's how we do it. We put it outside of the atmosphere. So wonderful question. All right, and let's see, maybe the last question here. How many stars are in the universe? Nice. So, okay, so in a nutshell, we don't know. Scientists are discovering new stars literally every day. But I do believe I read a figure once that it was at least something like 70 sextillion, I think that is. So that's 7 with 22 zeros after it. Like, I can't even fathom how much that is. So it's a lot. Of course, we can't see them all, though, from where we are here on Earth. So that number is closer to something like 7 or 8,000, I guess. But there is this idea that might help you wrap your head around it a little bit better, was that if you took every grain of sand on every beach that is here on Earth, so every tiny little, microscopic little bit of sand, if you were to count them all up, there would still be more stars than that even. So it is an incredible amount to wrap your head around, but maybe that'll kind of help you to sort of understand. It's just so much. We don't even know. There's so many out there. And of course, we are only scratching the surface of, investigating what our universe is like and seeing it too. So great question. And thank you for asking that, as we now, have so many more questions about the universe. That's what's so amazing about it, is it'll never stop. We'll learn new things and have so many more questions, huh? All right. So my friends, we have reached the end of our Star Stories program. If you do have any other questions about our programs or this program, you can reach out to us through our website, intrepidmuseum.org, or also through social media. Once again, the program that I used is called Stellarium, Stellarium. You can do a quick search on the internet for that if you'd like to try it at home. Maybe it'll be a little bit smoother. Mine was a little choppy for you today. But I'd like to thank you all so much for watching and sharing your questions and your comments. The museum has introduced a number of new live streams just like this, so feel free to follow and subscribe to this channel or visit our website for the latest streaming schedule. And also, if you are available, your donations of any amount will help to keep our programs free or low cost. So we also encourage you to explore becoming a member as well. So our next family program is going to be Tuesday at 3 p.m. and it's going to be called Intrepid Women. So we're going to be kicking off Women's History Month by highlighting some of the brave and unsung women who paved the way for the inclusion of women in air and space. Once again, that is going to be Tuesday at 3 p.m. right here on our streaming platforms. So once again, everyone, I would like to thank you so much for joining us today. Hopefully, we will see you for an upcoming program. Thanks so much, everyone. See you next time.